All right, so I'm going to do a combination lesson of 4.8 and 4.9. A lot of those two lessons are done with scientific calculators, which we don't use, so we're not going to go over those parts. But we are going to go over the graphing and writing of polynomials. It encompasses most or all of the information we've been doing through chapter 4. So what are factors? What are zeros? What do they look like on graphs? How do you take them off of a graph? How do you graph a polynomial? And then how do you write it if you're given a picture of the graph? So we're going to go through those different things. All right, so one interesting thing, fun facts about factors. If you have a single factor, like you're just given x plus 2, it's a factor one time. Your point goes straight through that, right? So your graphing, you go straight through that point. But if you are given a double factor, we call it bouncing off of a point. It means it's going to hit that point twice. It's going to hit it going down and then hit it going up. So it bounces off. I'll show you what that looks like. Okay, so I'm going to show you that as well as how to do these problems. Number 1, we need to graph this polynomial. It's in factored form and describe the end behavior. The end behavior is necessary to know because it's going to tell us how to graph it. All right, so this is what we're given. F of x, f of x is 1/6 x plus 3 times x minus 2 squared. That squared means I have this, 1/6 x plus 3, and this is that double factor. You see how it's squared? That means I have two of them. I have an x minus 2 times x minus 2. That tells me right away I have a double factor here. So somewhere on my graph, I'm going to be bouncing off of that point. So this is how I do it. I'm going to take those factors. I'm going to turn them into zeros. And zeros on a graph are your x-intercepts. So I have x plus 3, x minus 2, x minus 2. So those zeros, what would x have to be to make a 0? -3, 2, and 2. So I have 3 x-intercepts. I have -3, 0, 2, 0, 2, 0. All right, so I need to put those intercepts on my graph. So 2, 0, 2, 0, it just means it's going to bounce off that point. I'll show you what that means. And -3 only happens once. All right, so there are my zeros. Can you graph it? No, you can't graph it at all right now. How do you even connect those? Is it a V? Is it a scoop? Is it a wiggly? We don't even know. So the next piece we need to find is our y-intercept. Your y-intercept is when x equals 0. So I'm going to put that in my function. So 1/6, 0 plus 3 times 0 minus 2 squared. I'm going to solve that. So I have 1/6 of 3 times 0 minus 2 is -2 squared is 4. So I have 1/6 of 12, which is 2. So I have a point at 0, 2. Okay, so that's my y-intercept. But again, how do I connect those? All right, this is cubic, so it's going to be a little bit wiggly. So I need to figure out how do the ends behave. So end behavior. Okay, so we're going back. All right, so end behavior. All right, so my A value is 1/6. Oh, okay, so that's positive. So this is right side up. Okay, so I'm going to go to this far right point, and I'm going to point up. All right, how many factors? 3. Okay, so 3 factors means it's cubic or x cubed. Oh, that's odd. Odd means opposite. So if the right side is up, then the left side must go down. So I'm going to go to my far left point and go down. Now I need to connect those with a fluid pattern. All right, let's talk about that bounce. Since 2 is a double, it means it hits it going down and bounces off. Okay, so it goes here, bounces off. Okay, double factors bounce off. So now I connect, and if I put it into Desmos or my graphic calculator, it should look something like that. Not quite so pointy, but something like that. All right, let's try number 2. Graph and describe. Okay, so this is what we're given. So what about that can we use to try to graph? Your factors, all right? So let's write out our factors. So we have x plus 1. And if you have x minus 4 squared, do you only have x minus 4 once? No, you have it twice. That's what squared means. All right, and your factors, what are they good for? They give you zeros, so what would x be to output a 0? And it's -1, 4, and 4. What's the whole point of zeros? They tell you your x-intercepts. So we have a point at -1, 0, 4, 0, 4, 0. What is something unique about this point here? If it's a double, what should it do on our graph? It should bounce off of it. Okay? So 4, -1. What else do we need to know how to connect this? The y-intercept. So that's when x equals 0. So 1/2, 0 plus 1 times 0 minus 4 squared. So 1/2 of 1 times -4 squared, 16. So 1/2 of 16 equals 8. So we have a point at 0, 8. All right, so it's way up here. 5, 6, 7, 8. All right? We're going to call that 8 up there. But how do I know how to connect them? Okay, we need to find out our end behavior. So our a value, 1/2. What do we care about that? We care if it's positive or negative. So it's positive, so it's right side up. Go to your right side, point up. All right, how about our degree? If there are 3 zeros, what degree is it? It's a degree of 3, which is odd, which makes the ends opposite. So it is left side down. Go to your left side, point down. What do we know about that point right here at 4, 0? It bounces. So you come down, bounce off of it, go up and back through. All right, I'm not doing all of number 3, but you should have these x-intercepts. You should be going right side up, left side down. You should have a y-intercept at 0, 1.5. There are no bounces, so you're going to make a smooth transition through those.